So today we are going to start the numerical problems on the theoretical chapter, whatever we have studied. That is nothing but as your electromagnetic induction. So now in that electromagnetic induction, your page number 304. So in your exercise, first you have given the MCQ question. So in that MCQ question, your page number is 8 minutes. For your electromagnetic induction, your page number is 286. So your first MCQ, a circular coil of 100 turns. So you have given number of turns as 100. Then the second thing they have given, which is nothing but the cross-sectional area. So cross-sectional area is given as a 1 meter square. And the magnetic field, which is perpendicular, so magnetic field B. This magnetic field is perpendicular to the plane of the coil, and the value of that magnetic field is 1 Tesla. And what you have to find out? You have to find out the flux linkage. So your flux linkage, that is phi, you have to find out. Now what is the thing? We have a formula. Phi is equal to B into A. But you have a number of turns n. So there is a flux linkage multiplied by n. Now we are going to put the value. N is 100, B is 1, and your cross-sectional area is also equal to 1. So now what you are getting? It is equal to nothing but 100. And it is a phi. The unit of phi is nothing but Weber. So your first MCQ answer is 100 Weber. That is your option. Clear? Okay. Next, in your second MCQ, what is given there? A conductor of rod having length L is moving with velocity v in the direction normal to the uniform magnetic field. Means now if I am saying that this cross point will indicate your presence of magnetic field which is inside the board and perpendicular to the plane of the board. And we are keeping a rod which will be in the plane of the board. And now what I am going to do? I am going to move this rod with velocity v in the horizontal direction, and your magnetic field is inside the plane, perpendicular to the plane of the rod. So magnetic field is perpendicular. So what you have to find out, what will be the magnitude of induced EMF produced between the ends of the moving rod of the conductor. So between the ends, in between these two ends, what will be the magnetic field? So that derivation we have seen that EMF induced is equal to nothing but dl. That is nothing but your EMF induced between the ends of the rod given. Clear? Next, your third MCQ is there. In that third MCQ, you have, that is, now you have given the two inductors. So you have given the two inductors. Your inductor of 10 millifarad. So L1 is 10 millifarad. Then L2. L2 is given 20 millifarad. And what is the thing? They are connected in series. So I can say that let this is the one coil having inductance L1. This is the second coil having inductance L2. They are connected in series. And we have seen in theoretics, that is the when two inductors are connected in series, their LS can be written as L1 plus L2. In series combination, you have to just add these two values. And already you have knowing with these two values. L1 is 10, L2 is 20. Means your series inductance will be coming as 30 milli. That is nothing but your option number B. So your third MCQ answer is option number B. Okay. Then fourth one. In that fourth one it is given current through the coil of self-inductance 10 MD. So you have given self-inductance L is equal to 10 mH, millifarad increases from 0 to 1 ampere in 0.1 second. So you have given a current. Current will increases from 0 to, the second current is given as a 1 ampere. In time interval t is given as a 0.1 second. Fine. And what you have to find out? What will be the induced EMF in the coil? So now use the formula. Induced EMF in the coil is nothing but L di by dt in magnitude, where di is nothing but the change in current, t is nothing but the time taken during that change in current, and L is nothing but the self-inductance. All values are given here. So what I'll write? L, instead of di, what I'll say? L I2 minus I1 upon time is nothing but dt. L value is how much? 10 millihenry. So 10 millihenry, that's why 10 raised to minus 3. I2 minus I1, that is 1 minus 0. Upon time interval is what? 1 to 1. So now your calculation will come. 1 minus 0 is 1. Multiplied by 10 into 10 raised to minus 3. Divided by, instead of 0.1, what I say? 10 raised to minus 1. 10 raised to minus 1 goes into numerator, it will become plus 1. Means I'll write 10 into 10 raised to minus 3 plus 1. 10 raised to minus 3 plus 1, which is nothing but 10 multiplied by 10 raised to minus 2. So 10 raised to 10 into 10 raised to minus 2 means what? It is 0.01. This much. So this is nothing but your EMF induced in the coil. So 0.1, your answer is C. Clear? That is nothing but your fourth MCQ. Then your fifth MCQ, in which you want to find out energy build up. What is the energy required to build up a current of 1 ampere in a conductor of 20 millihenry? What is the energy? Means you have to calculate energy. Due to what? Due to current. Current is given 1 ampere. In inductor of 20 millihenry. So inductor 20 millihenry. Clear? So now I write formula of energy. Energy in the inductor E is equal to half L I square. This is the formula. In that formula, just you have to put the value of L and you have to put the value of I. So what I say? Half value of L is 20 millihenry. 20 millihenry, so 20 into 10 raised to minus 3. Then I is nothing but 1 square. So what I say that 1 by 2 multiplied by 20. So this 2 I will get cancelled with 20 as a 10. So what is remaining now? 10 into 10 raised to minus 3 multiplied by square of 1 is 1. Means how much I am getting? 10 into 10 raised to minus 3, which is equal to nothing but 10 raised to minus 2. Now it is energy. Energy means what? It is joule. Fine. But see your answer. In your answer, you don't have this answer. 10 raised to minus 2 joule. But you have all the answers. 2 answers are given in millijoule. And 2 answers are in joule. Means anyhow I can convert this 10 raised to minus 2 joule in millijoule. So what I say that if I want to convert into millijoule, I want to bring here 10 raised to minus 3. To bring here 10 raised to minus 3, what I do? I will multiply by 10 and divide by 10. So if I multiply and divide by 10, this 10 power, which will be for division, when it comes to numerator, it becomes 10 raised to minus 1. Means what I am getting? 10 into 10 raised to minus 3 joule. So 10 into 10 raised to minus 3 joule is equivalent to that of your 10 milli. Clear? So that is your option number A. So for your last MCQ, your answer is option number. Is it okay? Fine. Now we can go for actual numericals. Your numericals will start from, I can say, as a number 3, right? Question number 2, answer in brief. In that, 5 will be there, and after that, from 3 number, our numericals will start. So now I can concentrate on third numerical. What is given there? In Faraday disc dynamo, a metal disc of radius r rotates with angular velocity omega about an axis perpendicular to the plane of the disc and passing through the center. So now I can draw that diagram here. I will say here is the metallic disc. This metallic disc is rotating with angular velocity omega about an axis perpendicular to its plane. Fine? And the disc is placed in uniform magnetic field acting perpendicular to the plane of the disc. This is the plane of the disc. Right? And your magnetic field is perpendicular to the plane of disc. Means direction of magnetic field is here in upward direction. Fine? What is the thing? Determine the induced EMF between the rim and the axis of disc. Rim means this. This is to be called as a. So this I am going to call it as a rim. Now see here, your disc is, I can say, just like a bangle. This is the bangle. Here is the axis, and your bangle is rotating like this. So bangle is rotating in this manner, which is perpendicular to the magnetic field. Clear? And at that time, what will be your induced EMF? So what I'll say that from this center of this up till rim, I can concentrate as one of the distance. From that distance, I can select a small element dr here. This element is nothing but your dr. And now, total distance. This is center up till rim. Distance is r. So what I say that this particular element, I will say one of the element which will be at a distance of dr. So inside this element, whatever small EMF will be induced. So small EMF induced, dE, is equal to, according to your formula. Our original formula is what? EMF induced is nothing but BBL. Clear? But now what I say that element length is dr. So L will be replaced by dr. So here will be BL. Got it? Now this is nothing but the small EMF induced in here. Now if I want to calculate total EMF, means I have to take the integration. So total EMF is nothing but integration of dE. And limit of integration is what? In between where you have to find out? From axis of disc up till ring. So axis of ring will be passing through center and ring will be at a distance of r. Since your integration limits are from 0 to capital R. And integration of dE. So I put the value of integration, value of dE. Value of dE is nothing but your B, D, E, R. Fine. Now your disc is rotating with angular speed of omega. Is it okay? So now what I will do here, I will replace value of V from your rotational motion concept. V is equal to nothing but R omega. So I'll put that value of V here. So I'm getting EMF is equal to integration starts from 0 to capital R, B, V, R, dr. Now this B is uniform magnetic field. Then your omega, so here is the omega. Omega is a constant angular velocity of the disk by which it is rotating in the uniform magnetic field. So B and omega, that I will take out of integration. So inside the integration is what? R dr. And R dr integration, you are knowing R dr integration is nothing but R square by 2, and your integration limits are from 0 to capital R. Now I can put the limiting values. So first I'll put upper limit minus lower limit. So what I'm getting, EMF is equal to dW. Instead of small r, I can say capital R square upon 2 minus 0, because lower limit is 0. So what I'm getting, value of EMF? Value of EMF is nothing but 1 by 2 B omega into. So this much value of omega, this much value of EMF will get introduced inside this. Got it? If you are not getting, again repeat these steps in the video. If you won't repeat observing the steps in the video, you will absolutely miss. Fine? Okay. Next. The next, that is the problem number 4. In that problem number 4, just read that problem number 4 so that you can tell me the data. So you have given horizontal wire of length 20 long, extending from east to west. East to west means I can say that this is the rod, which is from east to west. And the length of this rod is nothing but 20 feet. Is falling into the velocity of 10 meters per second, normal to the Earth magnetic field. Now whatever Earth magnetic field is acting on this rod, this Earth magnetic field, that I can say that this is the direction of magnetic field, which is normal to the rod. And this rod is falling with velocity 10 meters per second, normal to the Earth magnetic field. So like this, your rod will be falling normal to the magnetic field. So like that manner, in this manner, rod will be falling. Like this, I have thrown the rod. So if I throw the rod in this direction, so this is the direction of velocity which is perpendicular to the magnetic field. So here is the velocity by which your rod will be falling, perpendicular to the magnetic field. So your magnetic field and velocity both are perpendicular to each other. If they are perpendicular, then you have given the value of magnetic field. You have given value of magnetic field is given to you, which is nothing but 0.5 into 10 raised to minus 4 Tesla. So 0.5 into 10 raised to minus 4 Tesla. And now what you want to calculate? You want to calculate there as an EMF induced. So in that case of EMF, again same formula, EMF E is equal to BLV. Finished. You are knowing all the things. Just go on putting the values. What is that? V is 0.5 into 10 raised to minus 4. L, length of the rod is 20 meters. The rod will be moving with certain velocity. The velocity of that rod, that data is given 10 meters per second. The velocity of the rod is 10. So now EMF, just go on multiplying. 20 into 10, 200. 200 into 0.5. Well, right here. 0.5 into 100, 5 by 10 into 10 raised to minus 4 multiplied by 200. One of the 0 will get cancelled. 20 into 5 is 100. 100 into 10 raised to minus 4. 100 into 10 raised to minus 4 means 100 means 10 raised to 2 multiplied by 10 raised to minus 4. So your final EMF will become 10 raised to minus 2. So this is nothing but your value of EMF induced in the rod. But again the answer is in millivolt. Means I have to convert this volt into millivolt. Millivolt means what? I have to bring here 10 raised to minus 3. But I have only 10 raised to minus 2. So to bring minus 3, I divide by 10. Means automatically I have to multiply by 10. Divide by 10 means this value will become 10 raised to minus 3. This value will become 10 raised to minus 3. Minus 3 into 10. So 10 into 10 raised to minus 3 fold. Answer is 10 millivolt. So this is nothing but your induced EMF in the falling rod perpendicular to the magnetic field. Clear? Okay. Next. Now your next question is about a metal disc. So again you have given a metal disc made to spin at 20 revolution per minute. So metal disc is revolving with frequency 20 revolution per second. So I can say that frequency is given as a 20 revolution per second. This is the frequency. Okay, next. About an axis passing through its center and normal to the plane. So again same thing, this is revolving about an axis passing through center perpendicular to its plane. Disk has a radius 30 centimeter and spins in the uniform magnetic field, which is parallel to the axis of rotation. So this is axis of rotation, parallel to axis of rotation means along this direction. There is a magnetic field. How much is the magnetic field magnitude? Magnetic field is nothing but 0.2 Tesla. This much is the magnetic field acting. Fine? And disk radius is given. The radius of the disk. This radius is given. Radius of the disk is given 30 centimeter. Centimeter you have to convert into meter. So 30 into 10 raised to minus 2. Clear? Okay, fine. Now first what is given? Area swept out per second by the radius of the disk. Area of the disk. Area of the disk means upper area and lower area. The upper area is pi r square, lower area is pi r square. Means total area swept out per second by the radius of the disk is nothing but 2 pi r. So area swept is equal to nothing but 2 pi r square. Clear? Now all data is ready with you. Radius is given 30 centimeter. So you can put that value. So here 2 pi multiplied by 30. 30 into 10 raised to minus 2. Centimeter has been converted into meter. Bracket square. Sample value. Clear? You have to do that because it is a simple calculation. Fine? Okay. Next. What is the next thing is given? You have given next thing the flux cut per second by the radius of the disk. You have to find out the flux cut. So I'll say that the flux cut, flux is nothing but phi. Its formula, phi is nothing but d into k. Right? Already this is your area. Fine? So what I'll say, b is 0.2 and this area, answer. So have you got your answer, which is nothing but, how much you got the answer? Okay, fine, I'll do the calculation. It is 2 pi multiplied by 30 square is 900 multiplied by 10 raised to minus 2 square is minus 4. So this plus 2 get absorbed here, so it is 18 pi into 9. Sorry, 9 is already multiplied here into 10 raised to minus 2. This is nothing but your area. So that area value I can put it here. 18 pi into 10 raised to minus 2. This much what? Flux. Flux unit is vapor. Area unit is nothing but meter square. So this is nothing but your flux cut per second. And now last is what you have to calculate? You have to calculate induced EMF. So now you have to calculate induced EMF. What is induced EMF? Induced EMF is equal to, according to your Faraday's law, Can anybody remembering formula? Faraday's law, E is equal to minus d phi by. So that is nothing but your flux. So per unit time here, already you have to find out this. This flux is flux per second. So that is nothing but your EMF. In same answer, I will just here whatever flux I am getting, that flux per unit time. So this value 0.2 into 10 raised to 18 pi into 10 raised to minus 2 divided by per second. So that is nothing but your, so that EMF value you will get it. Okay? Now the next, you have given problem number 6. Problem number 6 is a pair of adjacent coils has a mutual inductance 1.5 Henry. Current in one coil changes from 0 to 10 ampere in 0.2 seconds. What is the change of flux linkage with the other coil? You have to find out the flux change. Fine? But you are given mutual inductance. So you have to use the concept of mutual inductance. Okay, so just recall your formula where you will get mutual inductance. So your mutual inductance is M. Fine? And in mutual inductance, what we can say that phi is directly proportional to I. This is what I write down, phi is equal to M into. And what you want to find out? You want to find out change in flux. Change in flux means what? I have to differentiate change in flux per unit time is equal to M di by dt. This is your EMF. I want to find only change in flux, means I want to find out d phi. So just I am going to put the values there. Fine. So I will put the value. You have given mutual inductance. Mutual inductance is given 1.5. M is 1.5. Di is change in current. I2 minus I1 upon dt. In how much time interval? Time interval is given 0.2 seconds. So 0.5. Current changes from 0 to 10. Means value of I2 is 10. 10 minus 0 upon 0.2. So here what happens? 0.5 divided by 0.2. Decimal point will get cancelled. If decimal point will get cancelled, so automatically, sorry, your mutual inductance is given 1. So what I am getting? Decimal point will get cancelled, means I will get 15 multiplied by 10 upon. So 2 will get cancelled with 10 and a 5. So my answer will be coming 75. And change in flux. Change in flux means unit is nothing but J. Clear? So this is nothing but the change of flux with the what is fine. Now I will switch over to your next problem. Problem number 7. Problem number 7 is a long solenoid. Means now this problem is related with your last topic from the chapter. That is, in the last topic you have seen Ampere's law. And using Ampere's law, we have seen two applications. One is magnetic induction in a solenoid and magnetic induction due to toroid. So now out of that, here the problem is related to solenoid. So now solenoid. Right? Okay. Now what things are given in that solenoid concept? You have given a long solenoid consisting of 1.5 into 10 raised to 3 turns per meter. Means you have given turns per meter. Small n is equal to turns per meter. Small n is given. How much is given? 1.5 into 10 raised to 3. 1.5 into 10 raised to 3 turns per meter. This is given. Okay, second thing. Cross-sectional area of each turn is 25 centimeters square and coil is consisting 150 turns, tightly wounded around the center of the solenoid. Calculate for the current 3 ampere in the solenoid. So you have given current 3 ampere, area is given 25 centimeters square. So 25 centimeters square I can convert into meters. So 25 into 10 raised to minus 4 meter square. Okay. Now first A part is given. You have to find out the magnetic flux density. So you have to find out now magnetic flux density at the center of solenoid. So you have to find out the magnetic flux density. Okay. So now magnetic flux density. Magnetic flux density means phi upon 8, which is nothing but V. That is magnetic induction. Where in a solenoid. In a solenoid we have a formula mu0 I into small n. Okay, in solenoid we can use current as a small I, so I will take that small n. Now just go on substituting the values. So if you substitute the values, you will get answer. What is that? Now, mu0 value is 4 pi into 10 raised to minus 7. Current 3 ampere, small n, 1.5 into 10 raised to 3. Just go on doing the calculation. 4 into 1.5, that is 6. 6 into 3, 18. Into power of 10, 10 raised to power minus 4. Minus 7 plus 3, that is minus 4. Into pi. Means what calculation you have to do now? 18 multiplied by pi value. So 18 multiplied by pi. So 18 into 3.142 into 10 raised to minus 4. So if you multiply this both the factors, your answer will be getting 56.52 into 10 raised to minus 4 vapor per meter square. Flux density pi upon 8. Minus 4, instead of minus 4, I can write this answer as a 5.652 into 10 raised to minus 3 vapor per meter. So this is nothing but your magnetic flux density. Clear? Now, after that magnetic flux density, the next B section is flux linkage in the coil. Now, flux linkage, that you have to find out now. So, flux linkage, again I will switch over to that point. Flux linkage is nothing but N into phi. N phi, instead of phi, say D into T. Is it right? And now go on substituting the values. You have all values. Number of turns. It is given. How much number of turns they are given? Consisting of 150 turns. 150 multiplied by B value. Just now you have calculated. 5.652 into 10 raised to minus 3. Area is 25 into 10 raised to minus 4. Just do this one. That is nothing but your flux linkage. Clear? And the last point is average EMF. Average EMF induced in the coil if the current in the solenoid is reversed in the direction in a time of 0.5 seconds. Clear? So that you have to calculate. Do this calculation. If you finish this calculation you will get it as a flux linkage is equal to 2.119 into 10 raised to minus 3 Vapor. This is the flux linkage you will get. And now you have to find out EMF. So now Lee's law. Again, EMF is equal to minus d phi by d. But in this problem, what you have to calculate? If current in the solenoid is reversed in a direction in a time of 0.5 seconds, so your current direction is reversed. So the factor 2 will become here. So what I write? D phi 2.119 into 10 raised to minus 3 upon dt is 0.5 multiplied by 2. So like that manner, you can do the calculation. So you will get your final answer. You will get it as a 8.478. 8.478 into power. Power is getting as a 10 raised to minus 3. EMF. So unit is this EMF. Why this two factor will come? Current in the solenoid is reversed. So initially what happens? When current will be flowing in the forward direction, you will get the EMF in the reverse direction. When current will get reversed, EMF will be in the forward direction. I have to find out total EMF. So EMF will become double. I am not thinking about the direction. If we think about the direction, the net EMF will become 0. Right? You have to find out only magnitude. Okay. Now, your problem number 6. Problem number 8. You have given a search coil having number of turns 2000. Area is given, everything is given to you, and just you have to go on calculating you have to put the formula. In the values you have to substitute in the formula. So search coil means again we can consider the search coil is equivalent to your solenoid. Right? So now you have given number of turns. Number of turns are given 2000. Number of turns 2000. Area A 1.5 centimeters. That is given as a 50. Then the next point is given, which is nothing but magnetic field. So magnetic field B. Magnetic field B is given 0.6 Tesla. Coil is moved rapidly out of the field in the time interval of 0.2 seconds. So time interval is 0.2 seconds. That is given. What you have to calculate? Calculate the induced EMF across the search coil. You have to calculate induced EMF. This EMF you want to calculate. Clear? So now you have a formula, that is magnetic induction inside the solenoid. Magnetic induction inside the solenoid is nothing but your mu0 and I. That is nothing but the magnetic induction inside the solenoid. Fine? And now what I want to put? I want to put the value of EMF. So EMF is equal to what? D phi by dt. Phi. So let's say d dt of phi value is what? N A into B. N means, here capital number of turns. So let's say number of turns. N A B upon B. Number of turns is how much? 2000. Multiplied by area 1.5, but centimeters square. Centimeter you have to convert into meters square. So here what is say? 1.5 centimeters square means 1.5 into 10 raised to minus 4 meters square. Right? Multiplied by B, value of B. Value of B is what? 0.6. Divided by time interval. Time interval is what? 0.6. Clear? 0.6 divided by 0.2. Decimal point will get cancelled. So what I write? Instead of 2000, I write only 2 into 1.5 into 6 upon 2 into this 2000 can be written as a 2 into 10 raised to plus 3. Plus 3 I will add here, so it becomes 10 raised to minus 1. 2 through factor will get cancelled. 1.5 into 6, that is 9. Multiplied by 10 raised to minus 1, it is 0.94. That will be nothing but your EMF. Clear? Then, see that? Problem number 9. Aircraft of wingspan 50 meter flies horizontally in the Earth magnetic field. So now, we can see here, drawing is not so good, but still I'll try to draw that aircraft. So see that this is the aircraft. This aircraft is flying horizontally. And what you are given? The aircraft of wing swing of 50 meter flight. This total length. This is suppose I'm saying. This is the aircraft wing. So this length is given. Length is what? 50 meters. Okay, आगे आपका एयरक्राफ्ट का पॉइंट है. एयरक्राफ्ट है यहाँ पे. Aircraft. Just as if it is aircraft. Okay. Then, thing is what? We are concentrating on the wings of aircraft. So ये आपके wings of aircraft. इसका length कितना है? 50 meter. Flies horizontally in the Earth magnetic field. Earth magnetic field. They are moving in the horizontal direction. In the Earth magnetic field. You have given Earth magnetic field value is nothing but 6 into 10 raised to minus 5. So 6 into 10 raised to minus 5 Tesla. Okay. Then at the speed of, you have given speed 400 meter per second. Calculate the EMF generated between the tips of the wings of the aircraft. Tips of the wings. This. You have to calculate EMF at the tips of the wings. Means what? At the end of the rod. So, at the end of the rod, EMF induced E is equal to nothing but BL into, this is our general formula. So many times we have seen that. B is 6 into 10 raised to minus 5. Length of the aircraft wing is nothing but 50. And velocity. How much is the velocity by which that aircraft is moving? Which is nothing but your 400. So multiply that. Right? So now 6 multiplied by 10 raised to minus 5. And this multiplication will be coming 20 into 10 raised to 4. This power 10 raised to 4. Total power. Means what I write? 12 into 10 raised to minus 5 is 4. Which is equivalent to 1.2. EMF that's why this. So your final answer will be coming as a 1.2. Clear? Any doubt up till this problem? Everything is clear? Fine. Now today I will stop my lecture here, and from in the next lecture we can see the remaining problem. Okay.